Galaxies. Those pinpricks of light scattered across the cosmos are far more than just celestial decorations. They are vast, swirling maelstroms of stars, planets, and other celestial bodies. Our galaxy, the Milky Way, is estimated to contain up to 400 billion stars. But it's just one of many. Current estimates suggest that there could be as many as 2 trillion galaxies in the observable universe. So many beautiful and unique galaxy sizes and shapes. How did it all begin and how will it all end? Our Milky Way galaxy is quite large, but compared to others out there, it's actually relatively small. Andromeda, our nearest neighbor, is set to collide with us in the future. It's twice as big as our own Milky Way and is predicted to collide in about 4.5 billion years. If we stick around, we can expect a spectacular fireworks show in the sky, but even Andromeda, though large, pales in comparison. Enter M87. A colossal presence in our cosmic neighborhood. However, when considering all 3 of these galaxies together, their combined scale is dwarfed by the sheer magnitude of this cosmic monster. With a radius of about 2 million light-years and home to an estimated 100 trillion stars, it is one of the largest galaxies known to date, surpassing the size of the Milky Way by 60 times. How did it all begin? What causes galaxies to appear as though they are defying the rules of the universe? And what dark future awaits them? Our journey begins over 13 billion years ago in the early universe. Picture this, a vast expanse filled not with the vibrant galaxies we're familiar with today, but instead with an inky void. This seemingly empty space was, in truth, teeming with the building blocks of galaxies in the form of cold gas clouds. These silent, drifting clouds were the raw materials of the cosmos, the seeds from which the cosmic garden would grow. Composed predominantly of hydrogen and helium, these clouds were the leftover remnants of the Big Bang, scattered across the universe like a cosmic breadcrumb trail. Now the laws of physics, ever the architects of the universe, began to weave their magic. The force of gravity, subtle yet unyielding, began to draw these clouds of gas together. As the clouds of gas drew closer, they started to spin and swirl, forming vast cosmic whirlpools. This spinning motion was the result of the conservation of angular momentum, a fundamental principle of physics that dictates that the total amount of spinning motion in the universe must remain constant. In these spinning, seething maelstroms of gas, the first stars were born. Their fiery births lit up the universe, piercing the darkness with their radiant light. These stars clustered together, forming the first galaxies, the ancestral homes of all the stars, planets, and perhaps even life in the universe. These early galaxies were rough and unformed. Over time, these early galaxies would grow and evolve into the stunning galaxies we see today. As billions of years passed, these early galaxies began to change and grow. Imagine those galaxies twirl and occasionally collide, a process that has been unfolding for nearly 14 billion years. Initially, galaxies were just infants, small and irregularly shaped. They were composed mostly of gas and newly formed stars with little to no structure. As time marched on, these galaxies started to mature and shape themselves with gravity as their guiding hand. Galaxies began to interact with each other, pulled together by the irresistible force of gravity. Sometimes these interactions resulted in mergers, where 2 galaxies became one. This merging process often led to a burst of star formation, as gas clouds in each galaxy were compressed and ignited. The result? Galaxies started to grow, not just in size, but also in complexity. These mergers and interactions led to the formation of different types of galaxies. Some, known as spiral galaxies, are characterized by their rotating arms filled with stars, gas, and dust. Our own galaxy, the Milky Way, is a prime example of a spiral galaxy. Then there are elliptical galaxies. These are massive spherical collections of stars that appear to be completely smooth and featureless. These galaxies are typically the result of many mergers and contain older stars. With very little new star formation, our own galaxy could face a similar fate as a result of a destructive collision in 4.5 billion years from now. But the dance of galaxies doesn't stop there. Galaxies continue to evolve, driven by star formation, mergers, and interactions. Even now, our Milky Way is on a collision course with the nearby Andromeda galaxy. The chances of stars colliding during this event are highly improbable due to the vast distances involved. However, gas clouds will collide and ignite, creating a spectacular spectacular display in the sky for any observers on nearby planets. This collision will mark the end of both galaxies and the dawn of a new one, dubbed Milkomeda. As for Earth, it's uncertain whether we will be ejected from our galaxy to roam the cosmos or find ourselves amidst the chaos. But don't worry about that. The Sun is projected to transition into a red giant before the collision between the Milky Way and the Andromeda Galaxy, making life impossible on Earth before the collision. But there was mystery within those galaxies, with behavior that seemed to defy the laws of the universe, puzzling scientists. Over a century ago, when we first discovered these galaxies, we encountered something peculiar about them, almost as if they were defying the laws of the universe. Upon calculating their mass, we realized that there wasn't enough gravity to keep them held together. While most galaxies have a massive black hole at their center, its gravitational pull alone isn't sufficient enough to bind the entire galaxy. According to the laws of physics, the galaxies should have dispersed due to their own centrifugal forces, yet something was preventing this, and we wondered how. Moreover, the stars at the outer edges of galaxies, including the Milky Way, rotate at a similar speed to those closer to the center. This unexpected behavior of stars in the outer regions of galaxies, rotating at comparable velocities to those nearer to the center, was another galactic mystery. What force could hold those stars together as galaxies and make them move faster than physics suggests? This invisible force was later identified as dark matter, an invisible substance that appears to be everywhere throughout the universe. We don't fully understand it. It doesn't interact with matter or light. Its existence was confirmed thanks to the Hubble Space Telescope, which observed something bending light in a manner that could only be caused by a massive gravitational force. Subsequently, we discovered its presence everywhere. In fact, there is more dark matter than regular matter in our universe. Dark matter not only holds galaxies together today, but it may have even played a role in their formation. The clouds of gas coalesce under the influence of the gravitational pull of the dark matter webs, giving rise to the network of galaxy clusters and superclusters that we observe today. While dark matter played a pivotal role in the formation and sustenance of galaxies, there exists another disruptive force in the universe that ultimately leads these galaxies to their demise. A force exists that threatens the existence of galaxies and everything in our universe, known as dark energy. It operates in contrast to gravity by exerting a repulsive effect, pushing everything apart. As we observe the universe, it appears that everything is accelerating away from us, indicating the expansive influence of dark energy. In the distant future, this force is projected to isolate each galaxy, eventually leading to a profoundly solitary cosmos. However, for the present, let's cherish the existence of Earth and the vibrant tapestry of life it sustains. It's important to recognize that our very existence is indebted to the presence of galaxies. And within these galaxies, stars were born, planets formed, and ultimately life as we know it emerged. Without them, we would never have come into being. As we look up at the night sky, we are witnessing the result of billions of years of cosmic evolution, taking a glimpse into the past of our universe. This grand journey began over 13 billion years ago, allowing us to appreciate the beauty in our night sky. However, we won't be able to admire the beauty of our Milky Way with our naked eyes for much longer. Soon, it will be impossible to witness the beauty of the Milky Way. Watch the next video to learn why.